Let's look at configuring an XEM motion controller for pulse train outputs. The onboard motion controller and the PLC CPU are both housed in the XEM controller. If we look at the I/O parameter screen in the XG5000 software, we see that the CPU and its I/O occupy slot 0 and the motion controller is in slot 1. The motion control for the XEM is limited to single-ended, open collector outputs that use a pulse and direction signal output type. If we have an XEM DN variant, the outputs will be syncing, or NPN. If we have an XEM DP variant, the outputs will be sourcing, or PNP. It is important to note that the motion controller uses the CPU I/O for its outputs. The physical terminals that the PLC uses for certain %QX points will be the same terminals that the motion controller axes output pulse and direction to. It is also important to note that those outputs are hard-coded for specific axes. For the XEM CPU, axis 1 will always be %QX0.0.0 for pulse, and %QX0.0.6 for direction. Axis 2 will always be %QX0.0.1 for pulse, and %QX0.0.7 for direction. If we are using an H2 variant, all other output points are standard outputs. If we are using the 6-axis HP variant, axes 3 through 6 will use the %QX0.0.2 through 5 for pulse, and the %QX0.0.8 through 11 for direction. Avoid using these outputs in the XG5000 project if the axis they are assigned to is going to be enabled and used for motion. To set up our project in XGPM, we could either create a new motion project, open an existing motion project, or read a motion project from our motion controller. We cover this information, as well as connecting to the motion controller in another help topic. Please refer to it for further details. The XEM CPU will always have a valid motion project available, as even a fully reset PLC has a default motion project. Let's open XGPM from our XG5000 software interface, connect to our motion controller, and read the project to ensure we have the correct settings for our PLC and motion controller. We are using an XEM DN32HP for this example. Now that we have the project read from the motion controller, we will save it to our hard drive as example motion project. We need to set up an axis with initial parameters. To do this, we will go to the project window on the left side of the screen, expand number 1 axis data, and double-click on parameter. The new .parameter window opens showing all 6 axes. We will select the drop-down for pulse output under the 1-axis heading. We can then select Enable. This enables this axis for use with the XGPM and XG5000 projects. We will set the unit and adjust pulses per rotation, travel per rotation, unit multiplier, and speed limit to reflect the motors, gears, drivetrains, etc. of our specific motion system. For our example, we will be using the first 3 axes, so we will enable those axes. We will set the unit type to 0 pulse. Engineering units of millimeter, inch, or degree are also available. We will then set pulses per rotation to 1000 for each axis. Since our unit type is pulse, we can ignore the travel per rotation setting, as it is only used with engineering units. We will also leave unit multiplier at the default of x1, and we will set our speed limit to 3000 pulses per second for all 3 axes. If we keep scrolling, we immediately see there is an issue. The software has highlighted a few cells in red. Since we are using 3000 pulses per second for our speed limit, we will have to change the jog speed and homing high speed on all 3 axes to something less than that. Let's use 1000 instead. We can now save our project to our hard drive, and then write it to our motion controller by going to Online Write, or clicking on the icon of a computer with an arrow to a PLC. When we do, the Writes Project pop-up window appears. This window allows us to select individual axes and information we wish to write. This is a great way for us to only write the changes we care about and save some time during the write process. We will select the entire motion project to ensure we send everything we need to the controller. Once the project finishes writing, we have now set some initial parameters for our axes and are ready for motion programming.